According to National Electrical Code Section 620.24, entitled Branch Circuit for Hoistway Pit Lighting and Receptacle, there are specific requirements for electrical installations in elevator pits. Firstly, lighting is indeed required in elevator pits. This requirement is detailed in Section 620.24 of the National Electrical Code. Secondly, the lighting and ground fault circuit interrupter receptacle must be on separate circuits, as outlined in Section 620.24a. This section specifies a separate branch circuit for the hoistway pit lighting and receptacle or receptacles. Required lighting must not be connected to the load side of a ground fault circuit interrupter. Thirdly, the lighting switch must be readily accessible from the pit access door, as stated in Section 620.24b. This ensures that personnel can easily control the lighting when entering or exiting the pit. Fourthly, at least one 125-volt single-phase duplex receptacle must be provided in the hoistway pit, as specified in Section 620.24c. This provides a convenient power source for maintenance and inspection tasks. Now let's delve deeper into each of these requirements, providing a comprehensive understanding of the code provisions. Section 620.24 mandates a separate branch circuit for hoistway pit lighting and receptacle or receptacles. This means that the lighting and receptacle cannot share the same circuit breaker in the electrical panel. The primary reason for this requirement is to ensure that the lighting remains operational even if the ground fault circuit interrupter receptacle trips due to a ground fault. If both the lighting and receptacle were on the same circuit, a ground fault in equipment plugged into the receptacle could de-energize the lighting, creating a hazardous situation for anyone working in the pit. The phrase lighting shall not be connected to the load side of a ground fault circuit interrupter is crucial. It clarifies that the lighting circuit must be independent of the ground fault circuit interrupter protection provided for the receptacle. Connecting the lighting ahead of the ground fault circuit interrupter does not satisfy the requirement for separate circuits. The intent is to have two distinct circuits, each with its own overcurrent protection, typically a circuit breaker, in the electrical panel. This ensures that a fault on one circuit does not affect the other. To comply with this requirement, you need to run two separate branch circuits from the electrical panel to the hoistway pit. One circuit will supply power to the lighting fixtures, while the other circuit will supply power to the ground fault circuit interrupter receptacle. Each circuit must have its own dedicated circuit breaker in the panel. For the lighting circuit, select a circuit breaker size appropriate for the lighting load. The size of the circuit breaker will depend on the total wattage of the lighting fixtures. Consult the National Electrical Code Article 220 for guidance on calculating branch circuit loads. For the ground fault circuit interrupter receptacle circuit, a 15 ampere or 20 ampere circuit breaker is typically used. The ground fault circuit interrupter protection can be provided by a ground fault circuit interrupter circuit breaker in the panel or by a ground fault circuit interrupter receptacle installed in the pit. If using a ground fault circuit interrupter receptacle, it must be readily accessible and clearly identified. Section 620.24b addresses the location of the lighting switch. The code requires that the lighting switch be readily accessible from the pit access door. This means that the switch should be located near the entrance to the pit, allowing personnel to turn on the lights before entering the pit and turn them off upon exiting. The purpose of this requirement is to ensure that the pit is adequately illuminated whenever someone is present, minimizing the risk of accidents or injuries. The lighting switch should be installed at a convenient height, typically between 42 inches and 48 inches above the finished floor. It should be clearly labeled to indicate its function. The switch can be a standard single-pole switch or a more sophisticated control system such as a motion sensor or timer. However, the primary requirement is that it must be readily accessible from the pit access door. Consider the specific layout of the hoistway and the location of the pit access door when determining the optimal location for the lighting switch. The switch should be positioned so that it is easily visible and reachable from the entrance. Section 620.24c specifies the requirement for a duplex receptacle in the hoistway pit. The code mandates that at least one 125-volt single-phase duplex receptacle must be provided in the pit. A duplex receptacle is a standard electrical outlet with two receptacles allowing for the connection of two separate electrical devices. The purpose of this receptacle is to provide a convenient power source for maintenance and inspection tasks. Elevator mechanics and inspectors often need to use portable tools, testing equipment, and other electrical devices while working in the pit. The receptacle provides a safe and reliable power source for these activities. The receptacle must be ground fault circuit interrupter protected to minimize the risk of electrical shock. As mentioned earlier, the ground fault circuit interrupter protection can be provided by a ground fault circuit interrupter circuit breaker in the panel or by a ground fault circuit interrupter receptacle installed in the pit. If using a ground fault circuit interrupter receptacle, it must be readily accessible and clearly identified. The receptacle should be installed in a location where it is protected from physical damage. It should also be accessible and not obstructed by equipment or other objects. Consider the specific layout of the hoistway pit when determining the optimal location for the receptacle. In addition to the specific requirements outlined in section 620.24, there are other relevant code sections that should be considered when installing electrical equipment in elevator pits. Article 300 of the National Electrical Code provides general requirements for wiring methods and materials. This article covers topics such as conductor types, raceway systems, and grounding and bonding. Article 314 of the National Electrical Code addresses outlet boxes, conduit bodies, and fittings. This article provides requirements for the installation of these components, ensuring that they are properly supported and protected. Article 400 of the National Electrical Code covers flexible cords and cables. This article provides requirements for the use of flexible cords and cables in elevator pits, including restrictions on their length and application. Article 430 of the National Electrical Code addresses motors, motor circuits, and controllers. This article provides requirements for the installation of motors and associated equipment in elevator pits, including overcurrent protection and control circuits. Article 500 of the National Electrical Code covers hazardous locations. This article provides requirements for electrical installations in areas where flammable gases, vapors, or dust may be present. While elevator pits are not typically considered hazardous locations, it is important to be aware of the requirements in case there are any unusual conditions. Article 620 of the National Electrical Code, which contains section 620.24, is dedicated to elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. This article provides comprehensive requirements for all electrical installations related to these types of equipment. It is essential to consult this article in its entirety when designing and installing electrical systems for elevators and related equipment. Grounding and bonding are critical aspects of electrical safety in elevator pits. Proper grounding and bonding ensure that all metal parts of the electrical system are connected to ground, providing a path for fault current to flow back to the source. This helps to trip the circuit breaker in the event of a ground fault, minimizing the risk of electrical shock. The grounding and bonding requirements are outlined in Article 250 of the National Electrical Code. All metal raceways, enclosures, and equipment must be properly grounded and bonded. Grounding conductors must be sized according to the requirements in Article 250. The grounding electrode system must be installed in accordance with Article 250. It is also important to ensure that the elevator car and other moving parts are properly bonded to the grounding system. This helps to prevent static electricity buildup and minimize the risk of electrical shock. Overcurrent protection is another essential aspect of electrical safety in elevator pits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. This can occur due to short circuits, overloads, or ground faults. The overcurrent protection requirements are outlined in Article 240 of the National Electrical Code. Each branch circuit must be protected by a circuit breaker or fuse sized according to the ampacity of the conductors. The overcurrent protection device must be readily accessible and clearly labeled. It is also important to ensure that the overcurrent protection device is properly coordinated with the other protective devices in the electrical system. Wiring methods in elevator pits must be suitable for the environment. The wiring method must be protected from physical damage and moisture. Common wiring methods used in elevator pits include rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. Flexible metal conduit can be used in short lengths for connections to motors and other equipment. All wiring must be installed in accordance with the requirements in Article 300 of the National Electrical Code. Conductors must be properly supported and secured. Raceway systems must be installed in a neat and workmanlike manner. It is also important to ensure that all wiring is properly labeled and identified. Lighting in elevator pits must be adequate to provide safe working conditions. The lighting level must be sufficient to allow personnel to perform maintenance and inspection tasks safely and efficiently. The lighting fixtures must be located so that they provide uniform illumination throughout the pit. The lighting fixtures must be protected from physical damage and moisture. Emergency lighting must be provided in case of a power outage. The emergency lighting system must be designed to provide sufficient illumination for at least 90 minutes. Signage in elevator pits must be clear and easy to understand. Signs must be posted to warn of potential hazards such as electrical equipment, moving machinery, and confined spaces. Signs must be posted to identify the location of emergency equipment, such as fire extinguishers and first aid kits. Signs must be posted to provide instructions for operating the elevator and related equipment. All signs must be installed in accordance with the requirements in Article 110 of the National Electrical Code. Regular inspections and maintenance are essential to ensure the continued safety and reliability of electrical systems in elevator pits. Electrical systems should be inspected regularly for signs of damage, wear, and corrosion. Overcurrent protection devices should be tested periodically to ensure that they are functioning properly. Grounding and bonding connections should be inspected to ensure that they are secure and intact. Lighting fixtures should be cleaned and maintained to ensure that they provide adequate illumination. Any deficiencies found during inspection should be corrected promptly. It is also important to keep accurate records of all inspections and maintenance activities. These records can be used to track the condition of the electrical system and identify potential problems before they become serious. In summary, Section 620.24 of the National Electrical Code provides specific requirements for electrical installations in elevator pits. These requirements are designed to ensure the safety of personnel working in the pit and the reliable operation of the elevator. By following these requirements and implementing a comprehensive inspection and maintenance program, you can minimize the risk of electrical hazards and ensure the safe and efficient operation of elevators. Remember to consult the latest edition of the National Electrical Code and any applicable local codes and regulations when designing and installing electrical systems in elevator pits. Always work with qualified and licensed electrical contractors to ensure that the work is performed safely and in accordance with all applicable codes and standards. Adhering to these guidelines will help to create a safe and reliable electrical environment in elevator pits, protecting both personnel and equipment.